In this video, we're going to review how to solve equations that now contain exponents. So the only difference in these equations is now maybe we have an x squared or an x cubed that we didn't see before. But the rules for solving equations still stand. We're still going to think about our order of operations, so whether you use GEMS or you use PEMDAS, either one, and we're still going in the reverse order. So starting at the bottom, we're thinking about undoing each part of these by using the inverse operation. Okay, so that's where we have addition and subtraction are opposites, they invert each other. Multiplication and division are opposites. Now when I see exponents, okay, that's what our E stands for, I'm thinking about using a squared root or a cubed root in order to be able to undo the exponent that I see. As a reminder, when we solve equations, if I do it to one side of the equation, I also need to do it to the other side. So we'll be using these today as we go through our examples. The first example we're going to work through starts off as 5x squared plus 8 equals 253. Okay, as a reminder, this is 5 times x. We don't write the multiplication sign, but 5x is the same thing as 5 times x squared plus 8. So according to our order of operations, the first thing we need to do is the addition and subtraction. Since I see addition here, that means I'm going to have to subtract 8. And I'm also going to subtract 8 from the other side. It might help to draw that line down the middle to make sure that you keep your equation balanced. Okay, when I subtract 8 from 253, that gets me to 245. And on this side of the equation, my 8 cancels out. I now only have 5x squared remaining. At this point, add my equal sign. I now have 5 times a number squared equals 245. I now need to undo multiplication and division. And so I look over on the side, look where my multiplication and division is. I see multiplication, it's 5 times x. So to undo multiplication, I have to divide. So I'm going to divide by 5, because 5 divided by 5 is 1. So really that cancels out and just leaves x squared on this side. Since I divide by 5 on the left, I need to divide by 5 on the right side. I'm going to divide by 5. That gives me 245 divided by 5 is equal to 49. And now I have a choice. I can either look at this and say I need a number squared, so that means a number times itself that equals 49. Maybe I know what that number is, maybe I don't. If I don't know what it is, now in that order of operations, we've got PEMDAS or GEMS, whichever one you use, I'm going backwards and I'm undoing them. This is the exponent stage, because now I'm trying to figure out how do I get rid of the exponent. The inverse operation of that exponent for squaring is to use the squared root. If it was cubing, then I would need to use the cubed root. So here, if I want to undo the squaring, I need to find the squared root in order to undo this. That means I'm going to take the squared root of 49, leaving me with x equals, the square root of 49 is 7, because 7 times 7 equals 49. But we also need to remember, when we take the squared root, there are actually two answers, because 7 times 7 is 49, but also negative 7 times negative 7 is also 49. So my answer is going to be x equals a positive or negative 7. In our second example, we're going to continue this idea of solving equations. Again, we're still using the order of operations. So the very first thing when I'm using PEMDAS or GEMS is to go in reverse and undo them. So I'm thinking about addition and subtraction first. I always have to undo that part first. Since I see a minus 8, I have to do the opposite. So I need to add 8. That means I need to add 8 to the right side of my equation. And that's going to give me 62.5. After I do that, this cancels out. I would always rewrite your equation out so that you know what you still have left. Right now I have a number cubed, so a number times itself divided by 2 equals 62.5. Using our order of operations, I'm now undoing any multiplication or division. I see a divide by 2. That means in order to undo that, I need to multiply by 2. Those cancel out, and I need to multiply this side by 2 as well. On the left side, when I cancel those out, all that I have left is x to the third power. On the right side, I now have 62.5 times 2, and that's equal to 125. Now I've finished the multiplication and division step, I'm ready for the exponent step. I'm looking on the left side of my equation for where I see an exponent, and that's right here, x to the third power. Now to undo a third power, or cubing something, I need to take the cubed root. So I'm going to take the cubed root of 125, and again, maybe I know what that is, or maybe I need to use my calculator. I should get x is equal to 5. And in this case, there's only one answer. Because if I take 5 times 5 times 5, that's going to be a positive 125. But if I were to take negative 5 times negative 5 times negative 5, when I put these together, negative 5 times negative 5 is a positive 25, but now I still need to multiply by a negative 5. That would make a negative 125, which is not what I wanted to find the cubed root of. So my answer here is just a positive 5, so x equals 5. In our last example, we're still going to continue using that order of operations, but this time I might need to approach it from a slightly different angle. As a reminder, when I see this long fraction bar, the top of this fraction is actually in parentheses, so it might help me to remind myself and write them in. Because now, when I'm starting my order of operations, even though I want to undo the addition and subtraction first, this addition and subtraction is locked inside of this parenthesis, which is actually my last step. So I need to skip the addition and subtraction step and wait till I have the parentheses all by itself. So I'm going to move up. The first thing I'm actually going to do in this one is this multiplication and division step. Instead of dividing by 2, I see division. I want the opposite of that. I need to multiply by 2. All this does on the left side is cancel it out, so we don't actually have to do any thinking on that left side. We don't need to change the fact. We're just going to write down what's left. X squared minus 2. That's all that's left. That's equal to, now on the right side I do need to think a little bit. I multiply by 2, 1 times 2, that's 2. Now, all I have left is the parentheses, so now I don't need to write them. I can go ahead and erase them, and now I can start over and say, can I do any addition and subtraction? And yes, now I can. I have a minus 2, so the opposite of subtracting 2 is adding 2. We're going to add 2, that just cancels it out. We're going to add 2 to this side. 2 plus 2 is 4, and on the left side of my equation, all that's left is an x squared. Again, at this point, now I'm at the exponent step. I see an exponent and I want to think, how do I undo that? The opposite of squaring something is taking the squared root. So I'm going to have to take the squared root of 4, which means something times itself equals 4. That means we have x equals 2, because 2 times 2 is 4, but since we're using the squared root, we have to use the squared root rule, and it has to be positive or negative, because negative 2 times negative 2 is also a positive 4.